Alright, Assalamu alaikum guys, how are you all doing? So we'll be talking about elementary row operation under our linear algebra. And there are some certain things you need to understand under elementary row operation is that it is easy to understand because it helps us to understand Gaussian elimination and Gauss-Jordan elimination much more better, you get, whereby the analysis would not lead to paralysis. So you see something fascinating about elementary row operation that I want to explain is that literally, they used to usually call it directly as even Gaussian elimination, but I want to express them differently so that we can know how to apply Gaussian elimination to some certain questions step by step also. So under elementary operation, just a process whereby we need to break down some certain equations you are being given to much more sensible thing whereby you can just easily analyze. And these three things are certain that you can do. And since we know that the equation can be written in the augmented matrix form, that is like this part, then the first thing that you can do is that you can multiply a row by a non-zero constant. That's, you can have minus 2 times row 1, you can have minus 3 times row 2, you can have 2 times row 1, anything you want to do there. And you can also interchange two rows. Now, I will tell you why that interchanging of two rows is actually important. Let me come back to here. Now, if you remember from our simultaneous linear equation we did when we were applying normal baby elimination method to it, you know that we have x, y, x, y, you know, and whenever you look for x in equation 1, you find a way to what? To turn y into 0, because when you get x in equation 1, you need to get y in equation 2, just like a normal assumption method. And the moment you get x in equation 1, the y in equation 1 will become 0. Are you with me? And also the x in equation 1 will become 0 to get y. And if you look at now, in that point now, x has a coefficient which you can say that 1x. Y also have a coefficient which you can call 1y. So in that point, we have to find x, y, and z here. But we would now make a little thesis by saying we want to make it a little bit clear to us. And how is that? We need to find x here, we need to find y here, we need to find z here. So if I have x, x, s here, the moment I need to find x only in row 1, my problem is that I need to make these other ones, they should not exist anymore. That means I need to turn this other 2 to 0. How? I don't know. We'll move on, we see. Then the second one is that this is y in the next row. I need to find y in this next row. Are you with me? So my only problem is concerned about this second part. Why do I say that? Is that I don't have issue with the first one. I don't have issue. I don't want to know it. When you get to Gears Jordan, we'll start talking about having issue with all these ones. But literally basic today, just listen to the step. We'll break it down later when we get to the elimination, Gaussian and Gears Jordan. So I need y here. That's me having ordinary 1y, you know, not 4. So I need 0 here. Why do I need 0 is that I need to clear off the y that is here so that I can have ordinary z as an answer here. So the moment I have z as an answer here, I can sub z into here. Then I will have only y answers here. Then when I have y and z answer here, since I have y and z answer here, I can just sub it directly into what? Into these two equations. Z, y, then I get my x. Are you seeing the logic? So that means that we actually need a point whereby these three will be equals to 0, and this 3 here would be at 1. So this is going to be 1x, 1y, and 1z, you know, so that you can evaluate it directly. And I will actually urge you is that, you know, this is already 1, so directly we already have 1 here. It is an easy go. We can move on directly from there. But what I want to tell you is that if it was that there is no 1, let's assume you have 2 or something, you need to evaluate this first one first by having 1. But since they've given us 1, we just move on to the next aspect. Now, what you have to do is that the first thing you need to carry out as a step is that you need to turn this 2 to 0. Then the next one is you make sure this one becomes 1. Then the next one is you make sure this one becomes 0 back, and you make sure this one becomes 1. That's like a baby logic. When we get to the Gaussian, we explain the standard logic to ourselves. So what can we do now to make this second row, that's the x in the second row, to become 0? Like I told you, we can perform certain them. This is under, we are doing a row operation here. That's why we call it a row operation, and this is normal equation. So the moment you are breaking it down in the row, you break it down in the operation, also, that's in the matrix form. So we can say that's what minus 2 times, we are writing it normal. So when we get to Gaussian elimination method, we start using, you don't need to start writing it, we just go directly to the point by using what we call alphabet to specify some certain things. But let's write it down now to just clarify some certain things. Now we can say that minus 2, now why do I say minus 2? Guys, if I want to multiply row 2 by minus 2 all through, I can add it to row 1. If I multiply row 1 by minus 2 all through, I can add it to row 2. Now listen, whatever you want to perform, the function you want to perform has to be on one certain row. And my problem, the function I'm performing is based on row 2 now. So I can use anything. Whatever I'm doing will not affect any other row aside from row 2. So if I want to perform on row 3, whatever I'm doing, any other thing I'm doing will not affect any other particular row aside from that row 3. So if I say that minus 2 times row 1, minus 2 times row 1, you get what I'm saying? Minus times row 1 added to row 2. And in that point now, that means that I could have something like this. Now, minus 2 times row 1, I'm going to be having minus. So I told that it won't affect this because the action we want to perform is based on row 2. So I have my 1, 1, 2, then 9 back. Right? So minus 2 times row 1. Minus 2 times 1, you have minus 2. Minus 2 plus 2. What would they give us? You have 0. So minus 2 times 1, you have minus 2. Minus 2 plus 4, you have 2. So minus 2 times 2, you have minus 4. So minus 4 plus minus 4 plus minus 3, then that gives us what? Minus 7. Then minus 2 times 9, you have minus 18. So minus 18 plus 1, you have minus 17. Like I told you, it won't affect the third row either because our performance, or let me say the action we actually did, we want to perform is only based on the row 2. So if you want to write it also in this them now, are you with me? We can say that what? Minus 2 times equation 1 added to equation 2. So in that point now, like I told you, equation 1 would not be affected. You have your x plus y plus z equals to 9, right? And this point now, s has become 0, so it has actually, we look it like as if it is homeless. So you have ordinary 4y minus 3z equals to 1. Okay, we have 2y rather, that will break it down to you having 2y and minus 7z equals to minus 17. Doesn't affect this other one. You have 3, so you have 3x plus 6y minus 5y minus 5z rather equals to 0. So hope you can see that we've getting this one to be 0. Then what next do we do now to make this other, like I said, make this other point 0 also? So what do you think we can do to make this other one 0? Then we have to think irrationally. Let me wipe off the board and let's move on. So, alright, so when we look at our next point now, what we wanted to do next is that we need to make what? We need to make this other second point now. So let me just turn it there so that we can quickly see. Now we need to make this the 2, as you can see. I tell you that this second 3, we need to make it 0. And how can we do that now? We need to perform a certain operation. We can also say that what? This row 1, we can say that what? Row 1, multiply row 1 by negative 3. Then add it to what? To row 3. And the operation we are actually dealing with is what? Is under row 3. So let us look at the certain answers at which we can get under that. So from there now, we can say that what? Multiply equation 1 by negative 3. Add it to equation 3. And under row operation, we can say multiply, row 3 by negative 3, then add it to multiply row 1 rather by negative 3 and add it to row 3. So under that's them now, we know that what? We are less concerned with row 1. We don't have issue with row 1. Like I told you, our problem is based on row 3 because that is where the action wants to be performed, which wants to turn this to 0. So we don't have issue with equation 2 also. 0 to negative 7, we have minus 17. So the question tells us that multiply equation 1 by negative 3, then add it to row 3. So minus 3 times 1, you have negative 3. Negative 3 plus 3, it gives us what? 0. Are you with me? So minus 3 times 1, you have minus 3. Minus 3 plus 6, you have ordinary what? Your 3. Are you with me? So minus 3 times 2, you have minus 6. Then minus 6 plus minus 5, that gives us minus what? Minus 11. Then minus 3 times 9, that gives us what? Minus 27. Minus 27 plus 0, you have minus 27. Are you with me? So by breaking down our normal equation also, you still have your x plus your y plus your z to be equals to 9, plus 2z rather, to be equals to 9. Sorry, there's a little typo in this part also, 2z equals to 9. So from here, 0 has been cancelled. You have 2y minus 7z equals to minus 17. Then here, we have 3y minus 11z equals to minus 27. Hope you can get what I'm saying now. So I tell you that what the first thing that we make this 2 0, then we make this one 1. And how can we make this one 1 now? Is how you can, it's like I told you that what you can multiply a row through or through the row throughout by a non-zero constant. It can be fractions, so why is not 0? So I can easily say that what multiply equation 2 by 1 over 2. Are you get what I'm saying? That is, I can say multiply row 2 by 1 over 2. And by doing that, I don't have issue with row 1. I have 1, 1, 2, then my 9. So my problem is row 2. 1 over 2 times 0, I have 0. 1 over 2 times 2, I have 1. Then this becomes negative 7 over 2. This becomes minus 17 over 2. Right? So we are on the right track. So then nothing affects this. You have 0, 3, you have negative 11, then you have negative 27. So from this aspect, you can break this down. You have x plus y plus 2z equals to 9. This becomes y minus 7 over 2z equals to minus 17 over 2. And from here, you have 3y minus 11z equals to minus 27. Hope you get my logic. So we turn this to 0 first. Like I told you, if it was like this one is not actually at 1 normally as the question is being given. This is the first thing to change to 1. Then change this to 0, 0. Then literally we change this to 1. Now we are coming back to this to change this to 0. So how do we tend to change this to 0? What can we do? What can we do? What can we do? Let's think extensively. So what do you think we can do? And I feel like if we are to multiply, now you look at, if I'm to multiply negative 3 by equation 1, it will affect this 0 back. You get it will affect this 0 rather back. Because if I say negative 3 times equation 1 minus this one becomes 0, but this one will become minus 3 back. Because it will be minus 3 plus 0 minus 3. So we can't choose equation 1, we can literally choose equation 2. Because I want to find this to change this to 0. Then I can say that I want to multiply equation 2 by negative 3. Then add it to equation 3. Right? Negative equation 2 by negative 3, then add it to what? Equation 3. Then I can say multiply row 2 by negative 3, then you add it into row 3. Are you get what I'm saying? So like I told you, we don't have issue with row 1. You have 1, 1, then you have 2. So we have 9, right? So we multiply row 2 by negative 3. So we don't have issue with row 2 either. It's 0, 1, negative 7 over 2, negative 17 over 2. So from this aspect now, you are multiplying row 2 by negative. So negative 3 times 0 will give you 0. 0 plus 0, you have your 0 back normally. So negative 3 times 1, you have negative 3. Negative 3 plus 3, that gives us what? 0. Are you get what I'm saying? So you have negative 3 times minus 7 over 2. So that gives us 7 times you have 3. So that gives us minus 21. That will give us 21 over 2. Then 21 over 2 plus we'll say 21 over 2 minus 11. So you have 21 over 2 minus 11. So that gives us what? Negative 1 over 2. Like I said, 21 over 2. Do not forget 21 over 2 then minus 11. That will give us what? Negative 1 over 2. So I have negative 1 over 2 here. Then also again, negative 3 times what? Times minus 17. So 17 times 3, you have 51 over 2. So 51 over 2, that's 51 over 2 minus what? 27. Minus 27. Then I have 2 times 1, 2. Then I have negative 3 over 2. Are you get what I'm saying now? So I have negative 3 over 2 by breaking that down. So moving on. From this answer now, I need to write it back also in my equation. From here, I still have my x plus y plus 2z equals to 9. Then here I have ordinary y minus 7 over 2z equals to minus 17 over 2. Right? Then here I have I only have z now. So I have negative 1 over 2z equals to minus 3 over 2. So at this point now, I need to do what? I need to start breaking. I think that we need to make this one 0, 0, The next one becomes 1, this one becomes 0. Then the last part we need to do is that what? We turn this one to what? To 1. So how do you think we can do that? We have to think extensively. So let's see. Let me wipe off the board. Alright, so if you have to look at this now, we need to make this one 1. And if you want to make this one 1, that's very quite easy. That means that we can just do what? We can multiply row 3, or say equation 3 all through by what? By negative 2. Right? So putting on that, we can say multiply equation 3 by negative 2. I will say multiply row 3 by negative 2. So from that aspect now, nothing concerns the equation 1. You have 1, you have 1, you have 2, you have 9, right? Then you have so under equation 3 is our problem, so you have 0, 1, you have negative 7 over 2, then you have negative 17 over 2. This becomes 0, you have 0, then minus, because minus 2 times 0, 0, minus 2 times 0, 0, minus 2 times minus 1 over 2, you have 1, and minus 2 times this, you have what? Minus 2 times minus 3, you have 6. 6 over 2, you have what? 3. That means that from this point, if you have to write it, you have x plus y plus 2z equals to 9. Then you have y minus 7 over 2z equals to minus 17 over 2. And also from that aspect again, you have, what do they call it? Z equals to 3. So getting one solution actually pave way for the rest. Are you get what I'm saying? So we getting one solution will actually pave way for the rest. And from here, from this point now, we can just bring out the equation to solve. So if you solve z equals to 3 into equation 2 here, you have y minus 7 over 2 times 3 equals to minus 17 over what? Over 2. So y will be equals to minus 17 over 2 plus 21 over 2. And that should give us 21 minus 17. So you have this gives us 2. Then we have negative 4 over 2. So you have 4 over 2 rather, and that will be equals to what? 2. So y is equals to 2. And from there you sub it into the last equation. So you have x plus 2 plus 2 times 3, you have 6 equals to 9. So you have x being equals to 9 minus 6 minus 2, and that will be equals to 1. So that means that x is equals to 1, y is equals to 2, and z is equals to what? 3. So from the aspect of view, I feel like we all understand the certain category of what I just break down. So this is application of elementary row operation directly, just to make this turn 0 and this to turn 1 or true. So like I tell you that people do approach it as also Gaussian elimination, but there are some little difference for you to call it Gaussian elimination, because Gaussian elimination will be the one to express or explain much more about this thing better. You know what I'm saying? So under Gaussian, that is where we have our row echelon form and the reduced row echelon form also under Gauss and Jordan. Gauss owns the row echelon form. Gaussian owns the row echelon form, while Gauss Jordan owns the reduced row echelon form. We talk about those ones in our next class under Gaussian elimination method and Gauss Jordan elimination. Please subscribe, like. Thank you so much.